Hello everyone, I welcome you all today in the lecture series of Cognitive Ergonomics. Today in this lecture series, we will start from where we left off in the previous lecture. In the previous lecture, we started to talk about the human-computer interaction. We discussed about the human, we discussed about the interface, we discussed about how different paradigms and interfaces are coming all together to assist us in the field of human computer interaction. We also understood in previous lecture that personal computing, decentralized computing, how it helped the it helped exponentially in the help the discipline of human computer interaction. Now what we see here is the same design which I showed you in the previous lecture, is that the humans are there. When humans are being involved here, then these several cognitive components are involved here, and these cognitive components are done through their sensory system, physical system, are interacting with the hardware, software of a system. Now, the interaction among them resulting into also in an helping us in understanding the artificial intelligence, how we can come up with an artificial intelligence in a neural network, building an expert system, robotics, machine learning, and natural language processing. This has to be the human centered approach, and now based on the interaction, the way human and machines are interacting, the way humans and computers are interacting, this is also an interaction design and an interaction oriented design, and here it is the human oriented design. There are different places where humans are interacting with computers. All these different contexts has its own challenges and provides an aid to the user. For instance, if you see this air traffic controller, the air traffic controller on the ground is coordinating and collaborating with the aviators who are flying aeroplane in the sky. Lot of simulation, lot of understanding, lot of complex cognitive tasks are happening here. The important thing here is that with what easiness, with how much easiness these operators are interacting with these systems, and with what easiness these operators are capable enough to solve the problem sitting on the ground of the aviator. Such challenges are not do not exist only in this discipline or in this context, but there are many more contexts where the operator's task is very challenging and complex in nature. Certain skills and capabilities which is required by the operator to operate the complicated and sophisticated system requires some level of support and easiness. This help and support, what we are talking about, can be provided with the easiness between the interaction between the user and the system. Now, the operator, when he is dealing with the sophisticated system of like fMRI, then not only he has to understand how the system works, but also what is the output and what is the interpretation of the output as well. Such understanding, such interface interaction is highly demanding. Such interface interaction is very challenging, and because of this, in previous lecture we also discussed about the schema map, cognitive map, mental models, and how they are contributing and helping in the human cognition. How the cognition of the person, the operator, the analyst is going to influence the performance, efficiency, and satisfaction at workplace setting. If you see the naval officer, not only he has to navigate himself in the tide or under no tide condition, but he has to coordinate with the other onboard employees. Such coordination requires high level of cognitive processes. Such are very common examples towards us, which is giving an idea altogether the importance and relevance of cognition in ergonomics. When we alone talk about the human factor itself, then we understood very soon that human computer interaction, humans' role are very much important in this interface. And when the human computer interaction came into existence from 1970 to 1980, since then, last 4 decades, things have changed drastically. There are several design principles which people have talked about. And in this lecture series, we are going to address such small components of interface, small components of design, how they are playing a crucial role and helping in the efficiency and performance of the user. Now, in the software interface design, as we have been discussing about, according to Schneiderman, the well-designed software interface can impact a well-designed interface can impact the learning rate at which person is learning. So the interaction which we are having today online, if this interface is not robust, if this interface is not so clear, it may take more time to learn the same content related to a condition where the information is presented in a very simpler form. We have to keep it extremely simple. Then only the interaction between human and machine, human and computer can be enhanced and promoted. When this interaction is easy and simple, then the learning time taken by a person is less. Similarly, when the learning time is less, the performance speed should be better. They should be performing well. If they have learned well in less span of time because the task is easy, the performance should be better. How can we measure the performance? Accuracy and reaction time. Now, if the interface is easy, if the interface is effective, if interface is helpful and providing aid to the user, then the rate of the error will be minimal. Lot of human errors have occurred because the interface is complicated for the user to understand. In previous lecture, we have been discussing about the interface, and we also understood few examples of human error disasters such as Chernobyl, 3 Mile Radius, Bhopal gas tragedy, etc. and etc. Here we are talking about this software interface, but the same interface when a human is interacting with the machine in a big mechanical industry, there also an interface is there. It may not be a software interface, but it will be a physical interface which involves visual ergonomics or visual communication. And if any visual representation, visual communication is not up to the mark or do not have important characteristics, necessary characteristics, then the chances of error will be high. Person may make an error. If the learning time is less, if the performance speed is better, error rate is 0, then the user satisfaction will be high. So, error rate is inversely proportional to user satisfaction. Error rate is inversely proportional to learning time. Lesser the learning time, easy the learning is, minimal will be the error rate. Now, performance speed, if you talk about, performance speed is better, error rate will be inversely proportional. So, software interface design, if we are talking about, there is a monetary saving, there is a consumer product, money is involved, product is involved, but there is the possibility or probability of success and failure. The sophisticated systems are there, such as we saw earlier in previous example, the air traffic control system, where the aviator in the space is coordinating with the air traffic controller on the ground. Power utilities, naval navigation system, highly sophisticated, highly advanced systems. These systems provide a software interface design. It is very important for us to understand that the softwares, the modern softwares are capable and also are having lot many features, lot many life-saving features which people are using, and these features are providing an aid to help the driver who is not very good, the intermittent driver, to be an expert driver. Also, there are extreme weather conditions when an aviator is flying an aeroplane. These softwares can help in the critical scenarios. One thing we have to understand is that these software in the modern world is of great importance and relevance. People have been using these softwares for last 4 decades to get an aid and assistance. Now, when we talk about a software design cycle, how this software is being designed, then we have to understand the understanding behind the root cause of such a design, why such a design is there, what kind of design we can come up with, and then we have to evaluate also. We have to understand why do we need that specific software. So, if we see the 3 levels, 3 cyclic levels involved in the software design cycle, then first step is the understand, and here what we are able to see, error criticality. Error is there, some errors are complicated and difficult to understand, user experience and characteristics are there. We have to understand what my user has experienced, what kind of characteristic features my user is having, if he or she is capable to use such a software or such a design, what experiences they have come up with. And finally, what we have to also understand is the organization and the culture where we are going to apply this software. The second part is the computational and mental model. So, people are using several types of computational model, machine learning, to come close to the mental model. When the designer model is close to the mental model of the user, then the success of the design is very high. Moreover, we also need to come up with a theoretical framework why such model is working, but why the other models will not work. We need a robust theoretical framework so that we can understand the underlying root causes for such alteration and changes. We can understand what is the need of this software design cycle. We can understand what design cycle contribute. We can understand what challenges design cycle is facing. We can understand how can we make design cycle more robust. And finally, evaluation. Evaluation will be based on 2 types. One is the heuristic evaluation, the way different steps, different stages are involved, one has to evaluate that. Second, usability test and matrix. How much it is being usable? Is it effective to use? Does it have any challenges to use? Now, we can combine these three parameters together, and you can see it is cyclic in nature, which means once you understand the criticality of the error, why the error has occurred, what is the underlying cause of the error, you use the patterns, you use the goals, different functions, different tasks will be understood, will be analyzed, will be investigated, user characteristics and expertise, in which environment it is being applied, organization and culture. Now, once we have these understanding, we move to next level of design, where a theoretical framework is required, computational model is required, mental model and metaphors are required. Mental model, because we have a preconceived notion or we expect to have a design which is similar to our mental model, consistent with our mental model. Metaphors can provide an easiness with which the information can be encoded easily. Principles and guidelines, dialogue styles and standards. What kind of dialogue style is required, what kind of principle is applied here, those things we can list. Later on, heuristic evaluation, usability test and matrices, test and evaluation. Now, the coordination between these three variables, we have to understand that people have tried to use all these parameters to come to understand the user system. Now, this picture some of you might be familiar with, some of you may not be. This is a Word document picture from Microsoft 1998. Now, 1998 Microsoft Word was having so many features. More than half page is having the features. This type of featuring, we call it as creepy featuring, creeping featurism. Now, what do we mean with that? It is creepy because all the information is present there, and now it's complicated for us to understand which feature is important and which feature is not important. This user system characteristics, if we talk about, we saw minutes ago about the user system, creepism is there. So, the designer tried to reduce these content, and today if you open the Word, you will find a one line with very limited features. Most of the features have gone into drop down menu. Now, when we talk about user system and characteristics, functionality and use of the frequency of task performance. What is the frequency of task performance using particular software? If you are using it frequently, then you may be an expert in this discipline. Some features are mandatory, some features are discretionary use. So, this user system has to propose which system is mandatory and which system is discriminatory use. Third, knowledge level of the user. What is the knowledge level of the user? All these four components are going to help us in understanding the user system and characteristics. Now, as you can see on your left hand side, this first page 2000 is been divided into easy, expert, normal and hardcore. Now, with this understanding, we come to this slide where I would like to conclude. We saw few examples on interaction design, such as aviator example, analyst recording the MRI. Such examples clearly indicate the significance and relevance of human computer interaction. Another thing which we learned is the software interface design, followed by the software design cycle. And finally, we studied about the user system and characteristics, how we can strengthen this system and how can we boost its characteristics. So I will rest my case here. We will see each other in next lecture. Thank you.